So now we're going to get into what we'll call advanced data types. We already saw some of the primitives like ints, floats, and strings. And now we're going to get into some other types of collections of data, or so-called sequence objects. So we have lists, tuples, sets, and dictionaries. And we'll actually see that strings are also sequence objects as well, but we think of them a little bit differently. So first, let's start off with so-called tuples. So those are defined by these open and closed parentheses. So we'll say t equals 12 comma minus 1. That's of class tuple. We'll ask, is t an instance of a tuple? And we'll print the length of the tuple. It's true, and the length is 2. This means that there are 2 elements in that tuple. The tuple does not have to be the same data type, so this is not a traditional type of an array in that sense. 12, moni, true, and minus 12, 1.23 exponent 6. And we'll get the first element, and that's Monty. So you see here that tuples are basically just containers of other things. What's the minus 1th element, do you think? I can try to. What's the minus 1th element of t? Yeah. So again, like with strings, you can index starting from the back and going to the left. And just like with strings where we did slicing, minus 2 to the colon means we're going to start off going minus 2 here and then go forward. And you see what we got back? We got a tuple. Let's try that. So if you pull one element from a tuple, you're going to get back whatever type that element is. If you pull multiple elements from a tuple, you're going to wind up getting a tuple. X is equal to true, print the type. X is equal to true, comma. And you notice that I put the true inside of the parentheses here. So in the first case, it's Boolean. In the second case, it's a tuple. So a single element tuple is, the way you create it is with this comma, and then you don't put anything after that. And the reason why this is still a bool is because I didn't create a tuple, I just basically had a statement. Everything inside of the parentheses was a statement, and so there was no, it didn't create a tuple, so I could say or false, still a bool. Okay? So type of these parentheses and then comma, that's just asking me to do this twice, the length of that. So an empty tuple is just created with open and closed parentheses, and the length of an empty tuple is 0. What's the type of this? That doesn't make any sense. So you can't create an empty tuple with this comma here, but again, we could put one here, and then we get a tuple. All right, so single element tuples look like element, comma. Now, interestingly, you can't change a tuple, but you can concatenate them together. So if I want to set the second element to false, I can't do that, and Python tells me why. Does not support item assignment. Type of 1, comma, spam, comma, eggs, comma, none. That's a tuple. Now, if I actually wanted to take the first 2 elements of t and then put another element inside there, and then take all the elements after 3, the third element onward, I don't get exactly what I was expecting here. I wind up having a tuple, a 2-element tuple, and then I had false, and then I had a single element tuple after that, and all of that is a tuple. So what's the length of this thing that I just created? 3. What did I just do? Oh, because I want to set this. I don't know if that's going to work, because that's item assignments. We don't want to do this anyway. Let's do it. This is what we want to do. So you notice I can't get a length of this thing here, because it's thinking I'm giving it 3 different elements. If I put a parentheses in here, it should give it to me, 3. Okay, so that's not what we wanted above. Instead, just like with strings, if you want to concatenate tuples together, you would just do a plus sign. So this gets what I expected. Oh, can't concatenate a tuple, not a bool. Oh, yeah, right. Because this here is not a tuple. Just like with strings, when you want to try to create, let's say, I want 3 eggs and 2 spam, and you have the number 3, you have to cast that to a string. Here we have to cast this thing to a tuple. So we'll create a single element tuple here, and we get what we expect. Just like with strings, we can also do multiplication. So 2 of those 5-element tuples is just basically a concatenation. Okay? Any questions on tuples? Yes? What do you get again if you forget to put a parentheses for a single element tuple? If you forget to put a parentheses with a single element tuple, you'll wind up just getting the evaluation of the expression inside of the parentheses. Any other questions? Okay. Lists. So very similar to tuples, v equals 1, 2, 3 type of list, and that should be a length 3. I can slice into that. I can have lists that are not of the same type, just like in tuples. So I've got a bunch of strings here. I've got an integer. And then you notice my 4th element of that list is itself a tuple. And the 5th element is itself a list. I got 5 elements there. Now, unlike with tuples, I can actually do item assignment. So V0, the first element, I'm going to call it green egg. I'm going to add love it to the second element, and then I'm going to print out what the last element is. Now, the cool thing is you can actually go into the object that is pointed to with the -1th element, and that itself is a list, and then I can look at the second element of that. So I should get minus 3.5. Okay? So that's how I basically go into nested lists or nested tuples. -1, 1 is equal to none, so I'm actually going to do item assignment inside there and print out what v is, and you noticed I actually changed this element right here inside of the list inside of a list. I'll get all the elements from 2 onwards. And now we can make actually what looks like kind of a 2-dimensional array. So we'll make a new list called VV, and we'll make it a list of lists. And we'll print the length of that, which is going to be what? 2. Good. I can create the determinant for those that remember some from linear algebra. That's the multiplication of the elements along the diagonal minus the ones off the diagonal, and then print the result. That's -2. The important point is, and really the difference between tuples and lists, is that tuples are immutable, like strings, and lists are themselves mutable.
Can you just add extra parents to make it a tuple versus a list?
What's that?
You just add extra parents to make it a tuple versus a list?
You could, well, if you wanted to cast a tuple into a list or a list into a tuple, you can just say list parentheses or tuple parentheses, and if it can be cast, it will. So that's how you would go back and forth between those two things. That's not typically done, just because there aren't a lot of use cases around sort of casting back and forth that way. You might often take a dictionary and cast that into a list of tuples, but we'll see that later. All right, so lists can be extended and appended. Again, this is unlike tuples. So we have v is equal to 1, 2, 3. I can append the number 4, and that just puts at the end another element. So the nice thing about this is that when you create a list, unlike potentially with like C or Fortran, where you have to actually allocate a total amount of memory for that on disk ahead of time, knowing how many elements you're going to wind up having, in principle, you can just keep on adding and subtracting from lists. And Python will take care of the memory collection for you. So they have some, this dot append here is what's called a method. And a list, because it's an object, has methods. These are functions that are special to that object. It knows how to do things to itself. So in this case, when I append the number 4, and then I append another element here after that, you see what I wind up getting. I get the number 4 as we had before, but now my 5th element is itself a list of a single element, which is not potentially what I wanted to have, but this is how it got created. Now, if I want to just pare down V and only take the first 4 elements, and now I have W, and I'm going to add elderberries and eggs. and I can concatenate those together as well. You see I'm just growing out that single list. If I want to extend V with W, which is the other way to concatenate lists together, you wind up getting that result out. And you notice now that I didn't actually say V equals V dot extend. The extension method on a list winds up returning none, but it changes the list in place. So this list, think of it, for those that are comfortable with it, think of it as essentially a pointer, and there is an object which is pointing to the head of that list. And you can do things to that list, and as long as you're holding on to that pointer, you wind up basically being able to see the results. And the list itself knows how big it is and knows how many elements it has, et cetera. Now I can pop elements off of that list and get the result. Eggs, and you see what it did, it popped off that last element, and it actually changed the list. I can pop the 0th element and then print that out, and you see I took off the number 1 here. Was there a question? Okay. All right, so I can append the number 0 to the list, and I can add things to the list. So I added the 0 here, and then at the beginning I had another single element list, and the concatenation knows that I'm going to wind up getting a list back, and I wind up reassigning it to the value of V. So append, extend, and pop. You're adding, you're concatenating, you're removing elements from the list. Questions?
Can you append to the front of the list?
You could append to the front of the list. So if we do a question mark, here I'm showing you a little IPython stuff here, you wind up seeing not much information. That's kind of weird, that's not telling me what to do here. Append object to the end. No, okay, so then you can't do that. So then there is another way to do that. So if I do a tab completion on a list, so if you go list.tab, you'll see this thing pop up on your screen. Let's figure out how to do that. Oh, how about insert? That looks kind of good. Let's try insert. Okay, let's try that. V insert, so let's put it in the first place. What's your name? I can't spell Michael. Okay. I just showed you a little bit because I don't know everything in Python, and so when you try to figure out how to do something on the fly, you try to do this question mark for the thing you think you understand. It'll give you a little bit of a help string here, which you can remove here. Well-documented functions and methods will actually tell you a lot more about how to use them, et cetera. But then when all else fails, you just go in and you say, tab, I don't know, this looks kind of good. Look at all the different methods that are available for that list. Okay, so we can search and sort on lists. Yes?
How did you show the list of possible?
So there, all I did was I did the list, and then I did dot, and then I pressed the tab button on my computer. Okay, lists can be searched and sorted and counted. So we can sort this numerically. And again, you notice that the sort method on a list doesn't return a new list. It just returns a none, but it's actually in place changing the list itself. We can do a reverse if we wanted to. And we get it backwards. And again, if we didn't know how to use sort, it tells me that's a list, and then here I could type sort. And you notice that I have this thing called reverse. We'll see what the key does later on next week, tomorrow. Yeah.
I'm sorry.
Go ahead.
How does it sort if the elements of your list are different types?
Good question. We'll try that. We'll try one now where we actually do a sorting on floats and ints, and that should be clear. We'll also put in a string and see what happens. Do you have a question?
Different kind of methods. It looks like some of them can just kind of change the string in place.
Yep.
And some others you just have to assign it, kind of reassign it. Is there kind of any logic of how I know which ones, what I can do in place, which one I have to assign?
Yeah, generally objects that are mutable, many of those methods will just operate on the object and then you don't have to reassign it. Objects that are immutable will wind up returning a copy or a version of itself as the return. That's a general principle.
Like you showed how you can get the type or the class of the variable. Is there some way to test it, is it mutable or not? You just have to know.
You would just have to know, again, with the help functions, they should tell you what it's doing, and you see that it's returning a none. There's no standard documentation of exactly how the return should look in the documentation strings. But you can see here it's being very clear, I'm sorting in place. There is something called sorted. So that's a built-in function that you just have to know about Python that actually does the sort of an array and returns an array, or a list, excuse me. All right, so get back to the other question. Here, you see that it knows how to compare floats and ints. Let's try putting that in there. And it says, I don't know how to do that. Again, now there are ways that if you had your own special object in here, which was like a numerical type that you created, if you gave access within the object to essentially a method that allowed it to do comparisons with other things that aren't itself, it in principle could do it. But by default, it doesn't know how. Certainly, if it was a whole list of strings, it would know how to do the sorting on that.
Question: do you have access to the way in which the indices are shifted around so that you can apply that same sort to a different?
Yeah, there is the notion of an arg sort, and it returns back the argument, the elements that you'd have to index into to get back the sorted result. I can show that later on. Okay, so here we're doing the comparison. You notice I got access to the variable pi through the math library. Reverse, we saw the sort thing already. Now we can look up things by index, the fourth element, third element. We can count the number of times that 3 shows up. And you see that it showed up 2 times. We can insert at the 0th location, it's full of stars. And we can remove all instances of the number 3. And we should be careful, the first one element of the number 3. And you notice it took, even though I had an int, here I had a 3.0, because 3 and 3.0 are numerically equivalent to each other, Python decided to remove that one. So you notice it only removed one of them. If I did it again, it should remove the other one. Okay, so we've already sort of introduced this here. We said v dot remove. If you do tab completion, it shows you all the things that start with the letters that you typed in. And if you do shift enter on that, it shows you some more information about it. Okay? Yes? Yes, lists are much more versatile. Tuples are nice because if you're packing data around throughout your code base, and these are things that shouldn't change, like you're passing around an address book, and other parts of your application shouldn't be changing it, it's sort of a read-only. This would be a way to create a very complex object that itself would be read-only, pass it around, and you're still just passing the pointer around, you're not passing the whole thing. And then everything else, you try to access it, you'd get some exception, which is probably what you'd want to expect.
Aside from that, there are benefits of using tuples, or is it read-only?
What are some other benefits of using tuples? I think they take up largely the same amount of memory on disk, so there wouldn't be any difference there. All the methods associated with, there's different methods associated with them. So if you needed to be doing sorting, you could do a built-in function where you'd sort a tuple, but you'd get back a new tuple, which would create a new piece in memory. So that would mean that tuples, if you're using tuples like that, you're probably using too much memory. Generally, though, tuples aren't megabytes in size. They're sort of little packages of data. Okay, so we can iterate through these sequences, and lists are one of those sequences. So if s equals 1 and we're creating a new list, a is cat window defenestrate. You can see where this is going. So for x in a, This is a little bit different than we've seen before. Now, instead of like what you'd have to do in C or Fortran, where you'd have to create an index and then basically increment the index value, now we actually just directly get access to these individual values in this list. And each time this for loop is executed, we're going to wind up assigning x to the next value. So for x and a, so the first one will be cat, print that value, print the length of that value, and if it's cat, append a question mark to the end, and then we'll print the letter x.
So the counting is from 1, not 0?
Counting is from 0. So Python is 0 indexed. I decided to start x at 1. And the reason why I did that is because I wanted you to see what the scope was of, if I got rid of this x, first of all, I don't need this x. Let me pare this down to its little bare bones. X is equal to whatever this first assignment is, okay? And it's cat. When this is done, x is going to be this value of defenestrate, okay? Because that's the last thing x got associated with it. If I put x equals 1 here, like I had before, even though that's an int, the first time I go into this for loop, x is going to get assigned equal to cat. And I should still wind up with defenestrate, right? But yeah, I didn't use it yet as a counter. In the next line I will. What's that? X equals 2. Same thing. X can be whatever x can be anything it wants to, and it's still going to wind up assigning x equal to a, which is the first element of a. Then it's going to loop through and do window, then do defenestrate. Now, if you really want to keep track of the index during the loop, you can use something called enumerate, which loops over A and returns a tuple where the first element of that tuple is where you are in the loop, index-wise, and the second element is the actual value itself. One sec. So here, I'm basically assigning simultaneously I, which I'll call my index, and x, which will be the value inside of A, and I'm going to print the value of the index, I'm going to print that, I'm going to print the length. There's a question in the back.
So if you didn't define x prior to entering the loop, you just define a local variable.
Yep.
So the value of x will disappear.
Well, no, so it's a good question about local variables and assigning things ahead of time. I can call this variable anything I want. You know, I can call it zzz, and zzz, and zzz. And x right here at the end will be what x used to be at the end. That should be Gabor, because that's what I called at the end. But here, if I say zzz, it's going to be defenestrate. It's the last thing that zzz was assigned to. You don't have to declare this variable ahead of time. You're basically dynamically saying, hey, here's a variable, I'm going to call it zzz.
What happens now if you were in a new cell of print CZZ?
So it's saving the variables in what's called your local namespace, and zzz was last associated with this thing called defenestrate. Was there a question?
The index is basically in the list dense in the sense that the first one is always 0, and when you have an element in the list, the next element is always that index plus 1.
Yeah, that's right.
There are no gaps. Like one is 2, and the next index is 7.
No, if you wanted to step through a list and wanted to skip over, there's ways to do that with slicing operators. But when you're doing enumerate, it's just for you incrementally adding 1 to this counter. You could do this yourself inside of a for loop, right? So here you could say I equals 0, and then at the end you could say I plus equals 1, right? And then you could print I, and then you're basically creating that counter for yourself, right? 1, 2, 3. And you notice I printed it after I incremented it, so it didn't exactly look 0 indexed. But enumerate's a very, very useful and powerful thing, because now if you're looping through one list, but you want to use the index of where you are in that list to access another list, you could use that. Was there a question? So the question is, can you have a list with empty values? I don't know. Nope.
You had a variable that was nothing, right?
Well, you could have none. That's perfectly valid. Yes?
Is enumerate better than just using an index?
Is enumerate better than using an index? It could be. Again, it's dependent upon your use case. I'll show you how we use an index directly. And that's sort of more of the C construct of doing things. I almost always will just say 4x in the thing I'm looping over. And if every now and then I need to keep track of where I am in the flow, I'll also do enumerate. But very rarely will you actually loop through with the index and then have to go through and actually do the assignment. Memory-wise, I bet they're equivalent, and time-wise, I bet they're about equivalent to each other. It's just sort of nicer to read code-wise. So here, instead of it being X, which is a pretty terrible name, you might call it, noun. Although it defenestrates a verb, yeah. Okay, so enumerate is returning something. That's of class enumeration. And that itself is iterable and has various so-called methods associated with it. This is the first time I've shown you this underscore way of, this is basically just the name of a method, or it's a function that's associated with that object. This has basically, it's keeping track of this object of what comes next in the sequence. So the next thing in the sequence is 0 cat. What do you think the next thing is if I issue this again? 1 window. Next time again, what happens if I do it again? I've come to the end of the sequence. I raise what's called an exception, which is a stop iteration exception. And this is telling things that are using these iterables to actually say, oh, if you hit a stop iteration, it means you're at the end of the list, so just stop what you're doing. And you notice I didn't throw an exception when I ran enumerate here. It's because the for loop knows that when a stop iteration exception is raised, it should break out of itself. Yeah, Chris?
Why did you need to add in the double underscore before you just had object dot method?
Okay, so these are still methods. This is just the special convention of Python of effectively what are kind of hidden methods that are not typically accessed directly at the high-level code. This is getting you one level into it to show you some of the internals. So objects have lots of these underscore special methods. There's one for init. The way you would define how to add something is underscore add, underscore str, so what it looks like when a string. And different things who wind up calling that object will wind up calling those special methods implicitly for you. That's a great question. So, oops, mark below. B dot, sorry, let's try this again. B dot, you see that I'm not getting anything on the tab. I think there's a way to get. Okay, there you go. So the normal default behavior, I forgot this, of IPython is that if you do tab, it's only showing you the methods that are like effectively public. There is no everything is public in Python, so you can get access to any variable anywhere. For those of you that know like Java and public and private classes, don't worry about it. Except IPython doesn't show you those things unless you're doing the double, the underscore, excuse me. So here are all the things that are on that. You can't, so enumerate doesn't have an append method associated with it.
Oh, so enumerate can only have stuff that has underscore right now. You can't do anything without underscore.
Correct. Okay, so here I'm going to loop over A, and I'm going to print out, but instead of having a new line each time, I'm just going to do a comma and a space. Actually, do a space there. And so that way I don't have to print out a new line each time. Now, getting to one of the questions earlier about what if you actually wanted to use the index itself, here I could just basically create something called a range, which goes from 0 and has 4 elements, so 0, 1, 2, 3. So that's those 4 elements. And then I can loop over, let's see, I'll create a list around that range. I'll print that list. And then I'll print up the total sum of that list. So what did I do? I kept a running value with total equals 0, and I just kept adding the values as I wound up looping through. You could do this with enumerate. You could do this with the for in as well. And you notice here, now I'm just looping over a bunch of numbers and indexing into the value that I have in my list. Okay, so you don't have to just do a single number where you have a stop. You can also start at the number 1, go up to no more than 10, and then jump by 2 each time. You can also loop over strings. So here, this is kind of the typical way you would do it in the old school way. You'd say, well, I want to loop over however long my array is, and I get what I expect. Any questions about looping, about ranges, about the for in? Yes?
What does SGR of X mean?
SGR?
STR.
STR means string. So it's the string representation of X. And because X is a int, if I don't do that, it barfs at me because I'm trying to concatenate a string with an int. And you notice there's a way of breaking across new lines here in your code with this backslash. Does that make sense?
Yeah, I thought I just was associating strings with words and not with numbers. But you're saying this is actually just a value.
This is the value. So when I do this out, what this is saying is by adding the string value of the number 1, that's what this is doing right here. The total is now the string value of the total. Because what I'm doing is I'm accumulating the total value of X, and X itself are both ints, right?
Why couldn't I just eliminate STR in both, or just have plus X and then plus total?
So what are you asking me to do?
Eliminate STR in both lines. Because then I would be dealing with integers both.
Right, but what I'm trying to do is construct a sentence that has strings in it. So I'm trying to concatenate these strings. And one way to do that would be just have a bunch of different elements in the print statement. And then Python should know what to do. Any other questions? Yeah.
So we have this built-in functions and the methods belonging to objects. So those built-in functions, do they belong to any invisible objects or something, or just standalone?
So the question is about built-in functions like str, bool, bin. I showed pow. Those are built-in functions that can operate on things. Those just come sort of batteries included inside of Python. Those don't necessarily belong to individual objects. They know how to operate on objects. Now, an individual object may have its own method which has the same words or same letters of that same function, but it doesn't necessarily have to do the same thing.
The first example with the numbers, you have range from 1 to 10, so you go over those numbers.
Yeah.
Can you go on a range from commercial to legal?
No. So you couldn't range over the names of the values of those elements. Yeah. Range basically requires you to do it numerically because it's returning back an iterable which can be turned into a list of numbers that are in a sequence. All right, so let's go on to sets. These are denoted with curly brackets. So 1, 2, 3, bingo. Again, you notice the sets don't have to be homogeneous in the types. The type of that is a set. The type of curly brackets is, that's of type dict. That's a dictionary that we'll see a little bit later on. If I wind up printing out the type of this set, which is the empty set, that's the way of creating an empty set. Now, if I want to create this set of everything inside of spam let's do this way. I wind up getting a set of letters. And what's interesting about this is, of course, I've got multiple A's and multiple M's. A set is just a collection of objects. It's an unordered set, a collection of objects. Some of you, I suspect, will have a different, when you do this on your, in your Jupyter notebooks, you want to showing a different ordering. Does anyone get a different order? Or does everyone get the identical order? Same? Anyone on like a Linux or Windows machine get a different order? Yep, we got a different order. All right. So this is only to emphasize that when you're working with sets, Python really wants you to think about these things as unordered because it's doing whatever it wants to with hashing tables under the hood and just considering these as collections. If I did the set of a single element here, what do you think the answer is? It's spam-IM. It's a single element set, and that's because when you do a set constructor on a whole bunch of elements, it's just looking at essentially the outermost element. So if I'm looping over strings, I get what I expect. If I'm looping over lists, it's just looking at all the elements of the list. Okay? All right, so let me construct a bunch of sets, a set out of S and P, and a set out of A and M. So I get two different sets. I will construct the set of, again, bracket MA, and that's not going to be the same as B, right? Because what is C going to look like? It's AM. Okay. So wait, what? Oh, sorry. No, I want to make sure I made a mistake here. So before up here, I did a single element inside of this list. Here, I'm actually taking each individual character and making this a two-element list. So indeed, C and B are the same as each other. Okay, let me go back here because I made the mistake. So here is a single element, and the set of that is a single element set, because it's not able to loop inside of the individual letters. Here, I'm actually able to loop inside the letters because I'm saying, I've got a two-element list. And that is the same as having looped over this set right here with A and M. Is that clear? Okay. Okay, so C is that. Is P inside of A? Yes. Is PS inside of A? No, because PS is itself a single element, and instead I created this set of single characters. Let me create a new set, spam-IM. Is A a subset of Q? Yes. So A or B. A or B, and subtract off all the elements from Q. That's I. And then I can do a union where I have the common elements here. So this is kind of nice if you've got a very long list and you want to just figure out all the unique values. You can just say set of that list, and you'll get all those unique values. And then you can do set comparisons. Yeah?
So how does Python know that A is a variable, not that string?
The question is, how does Python know that A is the variable? So A is this, and A with quotes around it is that. So it's because when you're declaring a variable in Python, you can't have quotes around the variable name. Yes? Can you sort sets? That's a good question. Let's see. So Q is a set, right? If I do a dot, I can do a whole bunch of stuff, but I can't sort sets. Why is that? Because it's meant to be an unordered notion. If you really wanted to sort the sets that are in that, you would turn it into a list, and then you'd make it sorted. What is the point of set? Well, this is not a philosophy class. Yeah, it's really nice if you've got a big long list of, let's say, email addresses because somebody signed up for this bootcamp 5 times with the same email address. Instead of having to do something fancy within a list, I could just say set of the list, and I get all the unique email addresses of that list. So it's a very quick way of getting uniques. But if I now wanted to say, give me all of the people that were in the last bootcamp and are also taking this boot camp, then I know the people that didn't learn anything, and I can do the subtraction of the two or the union of those two things. I don't recognize you, so I think you're new. I don't want you, if you're here next year, we've messed up. I can remove elements from the set. I can pop things off the set. Yes?
Do you know if these behave like dictionaries as far as iterators go?
Do they behave like dictionaries as far as iterators go? In what sense?
The order will be the same as long as you don't change the set if you want to do that poorly?
You're ill-advised to loop over sets in that sense. What you would do is, if you wanted to be consistent behavior every time you run your code, you would probably cast your set into a list and then sort it by some way. Because every time somebody creates this, one of these sets, you're going to want, every time you run it, you're not guaranteed to have it work the same way on different machines. Yeah.
So what do you do when if you actually want to do, never mind the order, but you want to do the same thing to all the elements of the set? You want to multiply them by 2.
Yeah, so because the set is iterable, and I can iterate over it, and it has we can actually go and get another item out of that, you can use notions of like mapping and things, and you can actually loop over items that are in the set. You just aren't guaranteed the order at which that looping happens. So I can remove stuff from that set, and I can pop stuff off, and then if I want to print that set, it's empty set, and I can pop again, and you can't pop anything from the empty set. Unlike where I was popping with a list, where I was guaranteed to get the last element of that list, I'm not guaranteed to get any of those elements. It's just going to be one of those elements, and Python decides for you. Okay? And that's on purpose, that there is no kind of like well-established way in which it does that. Just in the interest of time, let me keep going on dictionaries. Looks like we're okay on sets. Dictionaries are actually quite powerful and useful. So these are an unordered, like sets, unordered grouping of key value pairs. So the way that looks is you create a key, which actually, for those that care about that, there's some hash function around that key, and then a value, a key, and a value. So we'll create a new dictionary. You can access the keys. This one, I'll basically say, what's the value of favorite cat? And that's none. I don't like cats. But D of 0, you notice, unlike a list, which has a 0th element, I don't have a key, which is 0 here. Okay? So I got a failure on that, but I did get the correct value of none first time I called this. E is equal to favorite cat of none, favorite spam is all, 1 is the loneliest number, in case you didn't know that. So there I can actually do what looks like a list index or a tuple index, except the reason why this makes sense is because I actually had a key, which was the number 1. The key can be anything which is immutable. So the key could actually be a tuple if you wanted to, but the key can't be a list. It can be a string because, again, strings are immutable. And again, just to remind you, dictionaries are unordered. So don't assume that they're going to be the same every time you run it. Lots of different ways of making a dictionary. Favorite cat, none. Favorite spam is all. That's the first way. We've seen that. You can also call the dict function, where you say 1, and you notice I don't have quotes around it, is equal to 1, 2 is equal to 2, cat is equal to dog, etc. And Python will make the quotes for you when it actually constructs a dictionary. I can also construct an empty dictionary, and then I can append to that dictionary. So this is nice because, like a list, you can start off with something small, and as your program winds up doing stuff, it can wind up adding and appending on to your growing list or your growing dictionary. And you can just keep on adding keys. The other way to do it is you create a list of 2-element tuples, and then you do dict on that list, and you get the same thing. Now you notice it printed out the same way for me on my machine each time. There's no guarantee that those would all be the same. And there's no guarantee across multiple machines. So is dict of my list equal to D? That's true. I can create a list out of a dictionary, and you notice what I get is just the keys. Okay? Any questions about that? Yeah.
Can you use a dictionary inversely? For example, that you don't look at cat, but you look at dog, and you expect to get that?
The question is, can you use dictionaries inversely, where you're just looking, you're saying, what's the key whose value is this? There's no direct way to do that with a built-in, but you could write a little function that does that. So you could pull over let's see, I have to think about how the most clever way to do that. You could actually create a new dictionary that flips those around and then just index off of that. We'll figure out another way to do it. You could have, exactly, so there could be conflicts as well. I assume you're assuming like kind of where there's a known one-to-one relationship of keys and values. Yeah, but there's no like built-in way to do that. Okay, so they can be complicated in a good way. Here's our original D. Here's a new D where it's actually the value is another dictionary. And the value here is another dictionary. So now, just like with lists, where I could go into the first element and then go into the second element, here I can go into the first key and then get the value of what's at the value of the next key. So of my least favorite cat is all of them. I can create a little dictionary. Yes? What's that? D is the variable name. I just did it for shorthand. It could be, you could call anything you want. Phone numbers. So this is a nice little phone book. I've got family and friends, and I've got now not as the value a dictionary, I've got a list, and the list is of tuples. Okay, so you see a little bit complicated, but what's nice about it is now I can print out my phone book. So what do I do here? I loop over the group type of family and friends. I print out what group it is. And then I add a little tab space here. I loop over all the elements that are inside of that group, and then I print out the values. I can get the keys, which is just family and friends of that phone number dictionary, and I could get all the values, and I get the last elements of those values. So I got the keys, and you notice what it did is it gave me friends, but here I wound up getting the last element of all the values. Let's see what all the values are. It's that. And you notice what it returned was a list of 2 elements, each element being a list, and the first list is a 2-element tuple. Okay, so instead of explicitly saying that I'm going to loop over family and friends, I can just loop over the list of keys. And then I'm not guaranteed which order it's going to be. Again, one of you could get friends and then family. The other ones might get family before friends. If I wanted to and make sure that this works the same on all machines, I would pull over the list of groups, and then I'd sort them to make sure that groups is always in the same alphabetical order, and then everybody should get family and friends. I could pull over items, which is different than keys. Items returns back a tuple, which is the key and the value. So now, just like we did with enumerate, where we set I and X in that loop, now I could just loop over all of the different groups and all the values within those groups. And then within a given value, I know that I'm just going to loop over those and print those out. So a bunch of different ways to do that, and depending exactly on how you want to present it in your code, you'll have to make some decisions. So what's the value of phone numbers of my coworkers? That doesn't exist, and you get a key error. Coworkers doesn't exist. Is coworkers in phone numbers? False. Now there's something which I haven't shown you before, which is get, which says give me the value associated with the key coworkers. Is this going to barf? No. It says I don't have that key, I'm returning none. Phone numbers of get friends is the same as phone numbers of friends. That's true. So these are just 2 different ways to index into this. What's nice about get is that you can have parts of your code which is potentially trying to pull over stuff that doesn't exist in the dictionary yet and may never exist, and you don't wind up breaking your code. Whereas if you said, you know, I want all the values associated with the key coworkers, if that's not there, you're going to raise an exception, which is probably not what you want to do. You can also set default values for get. So if coworkers value doesn't exist, then you can have it return something else, like all alone. I could also have it return none if I wanted to. Okay? What if I did this? Is it going to be none? No, because it sees that that's there. That's one of the valid keys. So it's going to return the values associated with those keys. Okay, and we can see what get actually does. So get k, and then here is just optional values here. If k is in D, else D. So D defaults to none. All right, let's set some values. BFFs in phone number keys. No, that's not there. Let's say we're going to append to the list that is the value of the key friends. We're going to add Marcia, and we're going to print out the phone numbers again, and you should see that indeed, in addition to Billy, now Marcia's my friend. Billy's phone number is changed, so let's just change that. Uh-oh. What happened? I wanted to just do item assignment, and I just did the normal thing. I went into friends. That's okay. What's wrong with that? And then I went to the first element. That's Billy. And then I went to this element right here, and his phone number changed. Why won't it let me do that? Because this is a tuple, right? And so in some sense, I protected myself from changing those phone numbers. If all of this data was up for grabs, instead of making all of these tuples, I might have declared the phone numbers dictionary to have basically keys and values where the values were a bunch of lists instead of tuples. Okay? So if I instead really want to change Billy's phone number, I got to change that whole element. And that's okay. I can set all my friends to 0 because I was spending all my time preparing for the Python class. I can pop off all the friends, and I can print the phone numbers, and you see I'm just left with family. Good lesson for you all. And we can delete the family, and then we're left with nothing in the phone numbers. It's an empty set. Very sad. I can use the update method, which is like the append method for lists. So this is basically saying, actually, we're going to update the key of friends. We're going to update that with some new values. And even though this was empty, an empty set, I basically just on the fly created a new key and a value. Any questions about that? The key didn't need to exist. I can create an enemy's key right there. If this already exists, that's a good question. So friends doesn't complain at me because I just reassigned the key to that value. You see that it wound up updating it. So it's a way of updating as well. So it's a great, dictionary is a great place to keep track of things that are changing. Yep.
With updates, can you change Billy's number?
Yeah, so can I change Billy's brother's Donald number? I certainly can. And that's fine because I'm basically changing all the value. So if it happens to be a tuple, that's fine. But I just couldn't index and say phone numbers, bracket, friends, 0, 1, and then change that because that is a tuple. So I can cast back and forth. So here's a list. I can take a tuple. I can turn a list into a tuple. And you notice that I'm not recursively going into this and turning everything into a tuple. I'm just turning the outer part of the list into a tuple. And I can do a list back, and I basically got what I had before. I can turn that into a set. I can do a list of a set, etc. Okay, so last thing here before we go into the next breakout session, we'll introduce the breakout session, and I believe we'll then have some time for lunch. You can be coding. After lunch, we'll wind up going over the solutions. So here, we can create lists on the fly by asking simple questions of other iterable data structures. So if I want a list of all numbers from 0 to 10 whose lowest 2 bits are 1, but not divisible by 11, because, you know, why not? The way we would have done this in the past is you would range over from 0 to 100. And you notice I have the 101 here because we're 0 indexed. And so I'm not going to get to 101. And I'm going to ask this truth statement. If I'm doing a bitwise comparison of 1, 1, and bitwise comparison of 1, 0, and 1, and the mod operator gives me no remainder, then I'm going to append it to my list, and I'm going to print out my list. So that's perfectly valid and perfectly fine Python. Instead, what I can do is this thing called list comprehension, where on a single line I can have this little bracket here, and I'll say number, give me the number, for the numbers in the range of 1 to 10, only if that number satisfies this truth condition here. This is what's called list comprehension. So on a single line, I can get the same result out. So if I don't have the if statement, what do you think I'm going to get? Yeah, get all the numbers. So this is very, very useful, very powerful. I can loop over all the mesons whose masses are between 100 and 1,000 mega electron volts. So here are all the particles. So I create a list of dictionaries, and these are 2-element dictionaries with a name and a mass. And now I can just do the filtering directly inside of this list comprehension, where I'm going to return not back a single variable, but I'm going to return back a tuple. So I'm going to get the name and the mass for x in particles if the mass is less than 1,000 and greater than 100. Okay, and now I'll loop over the results of that. I'll add up the total, and then I'll get an average of all the mesons in that mass range. Okay? So list comprehensions are quite useful. I can look at the first element and the name of that element. It's pion. And I can get, if I really wanted to, the byte encoding of what this pi plus actually is. Okay. So that's list comprehensions. You'll use this a bunch of times throughout the boot camp. I just want to introduce that here. All right, so we've got our breakout session. And this one's a little bit more complicated, perhaps a little bit more interesting. We've got a dictionary, which we'll call airports. And these are keys based on the 3-letter code of that airport and the long name of that airport. So DCA, Washington, D.C., MIA is Miami, et cetera, et cetera. And we have flights. So this is a list of tuples. And each tuple is 1, 2, 3, 4, 5 elements. Sorry, 1, 2, 3, 4, 5 elements. So it's the name of the airline, it's the flight number, it's the location where it's flying to, it's the gate, and it's the time in decimal hours of when it's flying out. And what I want you to do is print out a schedule organized by airline. So make sure it's nicely formatted as well. So we've got flight, destination, the gate, the time, et cetera. And then I also want you to print out a schedule that's organized by time. And that's hopefully is your incentive, that if you code well, you'll be able to eat. Any questions about the boot camp, about the second breakout session? Okay, have at it.